Okay, so welcome to the first chapter of Chem 631. It's on symmetry. And really this lays the foundation for the entire course. And we'll go through in this section why we use symmetry, how it helps us solve chemical problems, and the different elements of symmetry and some of the basics. But what you'll quickly see is that this is really the foundation, and all the problems that we subsequently do for the entire semester are going to be based on these core concepts. So this is like learning a new language. We're going to be practicing how to learn this language and how to identify and talk about elements of symmetry. And you'll get better and better at it over time, but it will take some time, and it definitely takes practice. That's the number one key for this entire course is practicing. So please, come to class and practice with me some of these problems and go over any questions you've had during these lectures that you've been doing at home. So why do we want to do symmetry? Well, why is it important? It's a fundamental property of much of the natural world. You can see in these organisms here, right? There's obviously lots of symmetry. But more than that, more related to our case of chemistry, is that there is symmetry intrinsic in the atomic and molecular wave functions embodied by quantum chemistry. So this is where this all comes from. And what we'll see in the course is that from this quantum mechanical starting point, we'll show that basically you can predict things about spectroscopy, whether or not a transition is going to occur or not going to occur. So it'll allow you to predict, for example, infrared spectrum. Let's say that's one example we'll go over, and many others, okay? And another thing that we'll see is that a lot of complicated problems can really be simplified by considering symmetric approximations. And a lot of times this is a pretty good approximation, okay? And so these are really the 4 different reasons why we study symmetry. And so just to go over some symmetry nomenclature, there's something called point symmetry, which is what we're going to be talking about exclusively in this course. And you can read the definition here. It's the symmetry possessed by a single object that describes the motions, rotations, inversions of a single object into itself. And I should just say, I'm not big on testing you definitions or anything like that, right? I'm big on you understanding the concepts. So I will give you definitions once in a while in the course, but really what I care about is you understanding the concept. So I'm not going to test you on a definition like this, right? So that's symmetry. There's also something called a symmetry group. And we call this a point group. And the point group is all the different symmetry elements together. So the key thing is it's a set. And for us, we're mostly going to be talking about molecules, right? So it's a set of all the elements, symmetry elements, that together give you all the symmetry information about that molecule. In contrast, there's something called space symmetry, okay? And this is in contrast to point symmetry. This is the symmetry describing the relationship of different objects in space, okay? So it's not just one point, it's across all space. And the corresponding group we call a space group when we're dealing with space symmetry. And this is basically a point group, but you also have the translation of space. So this is really important when you're dealing with crystal structures. We're not going to be talking about this in the course. There are other courses sometimes offered in the department that do go over this. So this is really important in crystallography. We're not covering crystallography in this course. We're going to be doing many other things. But that's what a space group is. So we're going to be focusing on point symmetry and point group.